Massive iron kettles boil animal fats and caustic alkali together, chemical reactions transforming these raw materials into soap through the saponification process that had served humanity for millennia, but now operates at industrial scale. Workers add salt to the boiling mixture, causing finished soap to separate and rise to the surface, while impurities and glycerin sink below, creating the purification that ensures quality in the final product. The separated soap is ladled into large wooden frames, where cooling transforms the liquid into solid blocks, systematic molding creating uniform shapes that will be cut into individual bars. Stamped soap bars emerge from drying rooms displaying manufacturers' marks and ready for wrapping. The complete production process, creating the hygiene products that improved public health throughout the industrial era. This is just part of the systematic process transforming fats and alkali into soap inside this 1840s steam-powered factory. Before we continue with the complete process, if you could leave a like and subscribe to the channel, it would really help this project continue bringing historical industrial content. Thank you for your attention. Now back to the video. Animal fats and vegetable oils arrive at the soap factory. Raw materials collected from slaughterhouses, rendering plants, and agricultural sources where these substances are byproducts of food production or dedicated oil crop cultivation. Tallow from cattle and sheep provides the primary fat source for most soap production, though manufacturers may blend different fats and oils to achieve specific soap characteristics affecting lather quality, hardness, and cost. Workers unload barrels and containers of fat, checking quality, and organizing inventory by type to enable proper batch formulation when production begins. The fats arrive in semi-solid or liquid form, depending on their composition and ambient temperature, with animal tallows typically solid at room temperature, while many vegetable oils remain fluid. The raw material storage area maintains organization preventing contamination between different fat types, as mixing during storage would complicate the careful formulation required for consistent soap quality. The alkali preparation represents the second essential raw material, with caustic soda or potash providing the alkaline chemicals necessary for the saponification reaction that converts fats into soap. The 1840s soap industry relies primarily on alkali, derived from various sources including wood ash, kelp burning, or increasingly from the LeBlanc process that produces soda ash from salt through chemical reactions. Workers prepare caustic solutions by dissolving alkali in water, creating the strongly alkaline liquid that will react with fats during soap making. The alkali strength requires careful control, as insufficient alkalinity produces incomplete saponification, leaving unsaponified fats in finished soap, while excessive alkali creates harsh soap containing free caustic that would irritate skin. This chemical preparation demonstrates the growing understanding of industrial chemistry, though 1840s soap makers still rely heavily on empirical experience rather than precise analytical methods that later periods will bring. The saponification process begins when workers charge the enormous iron kettles with measured quantities of fat and caustic alkali solution, initiating the chemical reaction that forms the foundation of soap manufacturing. These kettles, often holding several tons of material, are heated by steam coils or direct fire, bringing the mixture to boiling temperatures where vigorous chemical reactions proceed rapidly. The saponification reaction breaks down fat molecules into soap and glycerin, with the caustic alkali converting triglycerides into sodium or potassium salts of fatty acids that constitute soap's chemical structure. Workers monitor the boiling kettles carefully, maintaining proper temperature and occasionally adding additional alkali or fat to ensure complete reaction and optimal soap formation. The boiling process may continue for hours or even days, depending on batch size and desired soap characteristics, with experienced soap makers recognizing completion through visual assessment of the mixture's appearance and behavior. Steam power proves essential for soap production, providing both mechanical energy for pumps and agitators, while also supplying the substantial heat required for maintaining the high temperatures necessary for efficient saponification. The factory's boiler system generates steam that circulates through coils within the soap kettles, delivering heat uniformly throughout the large batches and enabling precise temperature control impossible with direct fire heating alone. This steam heating reduces fire risks while improving product consistency, demonstrating how steam technology transforms chemical manufacturing beyond its obvious applications in mechanical power generation. If you could leave a like and subscribe, it would help keep this channel active with quality historical content. Thank you for your attention. Now continuing with the process. The salting out process separates finished soap from the glycerin and other impurities created during saponification, producing the purified soap necessary for quality bar production. Workers add common salt to the boiled soap mixture, the sodium chloride changing the solution chemistry and causing soap to become less soluble while glycerin remains dissolved. The soap rises to the surface, forming a distinct upper layer, while the glycerin-rich underlay settles below, creating clear separation that enables removal of each fraction. This salting out may be repeated multiple times, with fresh brine added to further purify the soap and remove additional impurities affecting color, odor, or quality. The underlay containing glycerin is drawn off from the kettle bottom, often recovered for sale to other industries using glycerin in explosives, pharmaceuticals, or other chemical manufacturing processes. The purified soap remaining in the kettle displays improved color and reduced impurities compared to the crude saponified mixture, though additional processing may still be necessary for premium soap grades. Some soap production includes additional boiling stages with fresh alkali solutions, further refining the soap through repeated saponification and separation cycles that progressively improve purity and consistency. These multiple boilings create the fine toilet soaps commanding premium prices, distinguishing them from the single-boiled laundry soaps adequate for cleaning applications but unsuitable for personal hygiene use. The economics of soap production balance quality improvements against the additional time, materials, and fuel consumption required for extra processing stages, with manufacturers producing various soap grades, serving different market segments from economy laundry soap to luxury toilet preparations. The finished soap is drawn from the kettles, while still liquid and hot, ladled or pumped into large wooden frames where cooling will transform the fluid soap into solid blocks suitable for cutting and packaging. These frames, constructed to produce blocks weighing hundreds of pounds, sit on the factory floor or on wheeled carts, facilitating movement to cutting and drying areas after solidification. Workers pour the liquid soap carefully to prevent air bubble formation and ensure uniform filling throughout the frame's interior. The soap level in each frame is smoothed and leveled, creating flat top surfaces that will become block bottoms after solidification and removal from the molds. As cooling progresses, the liquid soap gradually thickens and solidifies. Chemical and physical changes transforming the fluid into the familiar solid soap structure through crystallization and setting processes occurring over hours or days, depending on ambient temperature and soap composition. The solidified soap blocks are removed from their frames, revealing massive rectangular masses of soap ready for cutting into the individual bars that will reach consumers. Workers may need to warm frames slightly to facilitate soap release, preventing damage to the blocks during demolding operations. The removed blocks display the characteristic color of the soap formulation, ranging from nearly white for heavily refined toilet soaps to tan or brown shades in laundry soaps containing less refined materials or retaining natural colorants from the raw fats. Cutting operations transform the massive soap blocks into manageable bars of standardized size and weight, suitable for retail sale. Workers mark the blocks with cutting guides, measuring precisely to create bars matching specified dimensions and ensuring efficient material use with minimal waste. Large knives or wire cutters slice through the soap blocks, the soft material cutting easily when proper techniques and sharp tools are employed. The cutting process produces stacks of rough soap bars, displaying cut surfaces requiring smoothing or stamping before final preparation. Some cutting operations employ mechanical frames fitted with multiple parallel wires, enabling simultaneous cutting of entire blocks into uniformly sized bars through single operations that dramatically increase efficiency compared to individual bar cutting. The cut soap bars undergo stamping operations that impress manufacturers' names, brand marks, or decorative patterns into the soap surfaces, creating product identification and aesthetic appeal that distinguishes various brands in competitive markets. Stamping presses apply substantial pressure, forcing metal dies into the soft soap, the compressed material taking permanent impressions that will remain visible throughout the bar's use. These stamps serve commercial and legal purposes, enabling consumer recognition while preventing counterfeiting of established brands that command premium prices based on reputation for quality. The stamped bars display professional appearance compared to unmarked soap, contributing to the growing importance of branding in consumer product markets. The stamped soap bars enter drying rooms where controlled air circulation and moderate temperatures remove excess moisture, hardening the bars and preparing them for wrapping and storage. The drying process proceeds gradually to prevent surface cracking or distortion, with proper ventilation removing moisture-laden air while maintaining conditions preventing excessive drying that would create brittle soap prone to breaking during handling. The drying duration varies depending on soap composition, bar size, and desired final moisture content, with workers monitoring progress and relocating bars through different drying zones as moisture reduction proceeds. Properly dried soap displays improved hardness and longevity compared to freshly cut bars, the reduced moisture content extending shelf life and improving handling characteristics during distribution and retail display. Quality inspection examines soap bars throughout production, assessing color consistency, odor, lather quality, and freedom from defects affecting appearance or performance. Inspectors test samples for proper hardness, checking whether bars have achieved adequate drying without excessive brittleness indicating overdrying or inferior formulation. Simple lather tests evaluate how the soap performs in water, generating foam indicating proper saponification and suitable composition for intended applications. Any bars displaying significant defects are separated for reprocessing, melting, and reformulating the material rather than discarding the valuable product. Approved soap bars receive wrapping in paper or fabric covers, creating protective packaging that prevents soiling and damage while displaying brand information and usage instructions. Workers wrap individual bars or create multi-bar packages depending on retail practices and customer preferences, with larger packages serving household purchases while single bars suit smaller purchases or sampling. The wrapped soap is packed into boxes or crates for shipment, organized by type and destination to facilitate distribution to wholesalers, retailers, or direct customers throughout the factory's market area. The soap industry serves growing markets driven by increasing recognition of hygiene's importance for health, with soap use expanding beyond laundry applications toward regular personal washing that reduces disease transmission. The 1840s represent a period when soap production scales dramatically, transforming from small-scale craft production toward industrial manufacturing that makes soap affordable for broader populations previously unable to purchase sufficient quantities for both cleaning and personal hygiene. The factory's production capacity enables consistent supply meeting growing demand, while standardized products ensure reliable quality compared to variable results from small-scale soap making. Inside steam-powered soap factories like this, chemical processing transforms animal fats and alkali into cleansing products through reactions operated at industrial scale. The machinery continues operating, prepared to receive new fat shipments and repeat the saponification, separation, and molding cycles, creating the soap that improves public health and cleanliness. Steam power provides heat for chemical reactions and mechanical energy for pumps and cutting equipment, enabling efficient production impossible through hand methods or simpler heating approaches. Workers combine traditional soap-making knowledge with industrial chemical processing, maintaining quality while achieving production volumes that make soap widely accessible throughout society, contributing to the public health improvements characterizing the industrial era. Did you know that the glycerin separated during soap making became a crucial ingredient for explosives manufacturing, making soap factories strategically important during wartime? If you enjoyed learning about industrial soap production from the 1840s, please subscribe to the channel, leave a like, and comment about what surprised you most. Your support helps us continue bringing historical industrial content. Thank you for watching. See you in the next video.